Welcome to Azure Security Series video number 4. Today, we were discussing about understand cloud security. Who am I? I am Sun Jia, Microsoft MVP. You can find me at my Twitter, Jia Sun, and also you can look for more tutorial at techconnect.io. For today's agenda, the first one is introduction to the shared responsibility model, overview of elasticity and scalability, understanding virtualization, container, and serverless computing. Let's get started. The first agenda, introduction to the shared responsibility model. Organizations face many challenges with securing their data center, including and keeping security aspect. Using many security tools and keeping pace with the volume and complexity of threat. Microsoft Azure is uniquely positioned to help organizations with this challenge. Azure helps protect business access while reducing security costs and complexity. Built-in security control and intelligence help admins easily find and respond to threat and security gaps, so organizations can rapidly improve their security posture by shifting responsibility to Azure. The organization can get more security coverage, which allow them to move security resources and budget allocation to other business priorities. The first thing to understand about cloud security is that different scope of responsibility exist, depending on the kind of service you use. For example, if you use virtual machine in Azure, which provide infrastructure as a service, IaaS, Microsoft will be responsible for helping secure the physical network, physical storage, and virtualization platform, which include updating the virtualization host, but you need to take care of helping secure your virtual network and public endpoint and updating the gas operating system of your virtual machine. For all cloud and deployment type, you own your data and identity. You are responsible for helping secure your data and identity for your on-premise resources and the cloud component you control. Regardless of the deployment type, you always retain the responsibility for the following: data, endpoint, account, access management. It is important to understand the division of responsibility between you and Microsoft in the software as a service SaaS, platform as a service PaaS, or IaaS deployment. Now we come to the overview for elasticity and scalability. The cloud requires a new method of management because it focuses on scale, elasticity, and automation. The cloud represents a paradigm shift in the way that we think about embracing IT. DevOps has completely changed the way applications are developed and maintained. The hyperscale nature of the cloud provides a completely new meaning to scalability, elasticity, and resiliency, and has refined how applications are designed and delivered. Cloud applications typically encounter variable workload and peak in activity. Applications should be able to scale up within limit to meet peak in demand and then scale in demand decrease. Scalability concerns not just compute instance, but other elements such as data storage, machine infrastructure, and more. This automatic resources allocation and deallocation is what defines the elasticity of the cloud. One of the Azure tools used to understanding how your applications are performing is Azure Monitor. Azure Monitor maximizes the availability and performance of your application by delivering a comprehensive solution by collecting, analyzing, acting on telemetry from your cloud and on-premise environment. The diagram on this slide gives in a high-level view of Azure Monitor. Let's continue to the agenda and understand virtualization, container, and serverless computing. Virtualization creates a simulate or virtual computing environment as opposed to a physical computing environment. Virtualization often includes computer-generated version of hardware, OS, storage device, and more. This allows organizations to partition a single physical computer or server into several VMs. Each VM can then interact independently and run different OS or applications while sharing the resources of a single host machine. By creating multiple resources from a single computer or server, virtualization improves scalability and workload, while resulting in the use of fewer overall servers, less energy consumption, and less infrastructure cost maintenance. Virtualization falls into four main categories. The first is desktop virtualization, which allows one centralized server to deliver and manage individual desktops. The second is network virtualization, which is designed to split network bandwidth into independent channels to then be assigned to specific server or device. The third is software virtualization, which separates applications from the hardware and OS. The fourth is storage virtualization, which combines multiple network storage resources into a single storage device that multiple users can access. And Azure VM gives you the flexibility of virtualization without having to buy and maintain the physical hardware that runs the VM. However, you still need to maintain the VM that is configured, update, and maintain the software run on the VM. Azure Virtual Machine let you create and use VMs in the cloud, providing what known as infrastructure as a service IaaS. VM technology can be used in a variety of ways. Virtualization creates a simulate or virtual computing environment as opposed to a physical computing environment. Virtualization often includes computer-generated version of hardware, OS, storage device, and more. This allows organizations to partition a single physical computer or server into several VMs. Each VM can then interact independently and run different OS or applications while sharing their resources of a single host machine. By creating multiple resources from a single computer or server, virtualization improves scalability and workload, while resulting in the use of fewer overall servers, less energy consumption, and less infrastructure cost and maintenance. Virtualization fall into four main categories. The first is a desktop virtualization, which allow one centralized server to deliver and manage individual desktop. Okay, so let us continue. Let us continue with the understand virtualization, container and serverless computing. A container is a modified runtime environment that prevents a program from accessing protected resources. A container interacts directly with the host OS and augments the containment function. A container does not use virtualization, so it does not waste resources simulating virtual hardware with a redundant OS. This typically makes containers more lightweight than VM. They help you use the container technology built into the OS. For example, one of the popular services is Azure Kubernetes Services (AKS). For container management, Azure Container Instance was released in April 2018. Container Instance offers an on-demand compute service delivering the rapid deployment of containers with no VM management and automatic elastic scale. The container instance connected for Kubernetes uses the Kubernetes API, deliver the per second billing and zero infrastructure execution of container instance. You can move existing applications to container and run them within AKS. You can control access via integration with Azure AD and access service level agreement (SLA). But Azure services such as Azure Database for MySQL and any data needs via Open Service Broker for Azure OSVA. Serverless. Previously, this video discussed responsibility zones for Azure deployment. With serverless computing based on Azure function, you can significantly reduce the customer responsibility. Serverless computing is the abstraction of server, infrastructure, and OS. When developers build a serverless app, they don't need to provision and manage any server, so they can take their minds off infrastructure concern. The reaction to events happens in near real-time drive serverless computing in the cloud. With a fully managed service, server management and capacity planning are invisible to the developer, and really is based just on the resources consumed of the actual time the code run. With serverless architecture, you simply deploy your code, which then runs with high availability. Azure Function. Azure Function is a serverless application platform. It allows developers to host business logic that can run without the need to provision infrastructure. Azure Function provides interesting scalability, and the customer is charged only for the resources used. Developers can write their function code in the language they choose, including C#, F#, and JavaScript. Azure Function also includes support for NuGet and npm, so developers can use popular libraries in their business logic. Functions are event-driven, which means they run only in response of an event trigger, such as receiving an HTTP request or having a message added to a queue. The developer configures a trigger as part of the function definition. This approach simplifies the code by allowing the developer to declare where the data comes from, trigger input binding, and where it stores output binding. Developer don't need to write code to watch queue, binary, class object, event hub, or other structure. They can purely on the business logic. Okay, thank you everyone. Thank you everyone for today. If you got any question, you can tweet me at my Twitter. For today's video blog, you can go to my dev.to/Jameson. Thank you very much.